A line graph is a common way of presenting scientific data. To decide if to use a line graph or a bar graph, you need to look at your independent variable and ask yourself two questions. The first one is, does the data consist of numbers rather than letters or words? The second one is the data continuous? What does this mean? Continuous data is data that can be measured on a scale, and it can take any value within a range. So for example, an example of continuous data is a person's height. So in the case of a person's height, if you think about it, an adult is expected to measure between maybe 1 meter 20 and 2 meters 50. So any measurement of height within that particular range is what we would consider to be normal. Yes? So that is continuous data because it can take any value within the range. Other examples are a dog's mass, or the time taken to run a race. So, if your answers to these two questions is yes, then you can proceed to draw your line graph. So in this case, we're going to use data from an experiment in which we measured how long it takes for ice to melt when placed at different water temperatures. So in this case, water temperature has been changed and I've measured the time taken for ice to melt. So in this case, water temperature is the variable I changed, so therefore water temperature is the independent variable, and time taken for ice to melt is what I measured, so that is a dependent variable. Now, if you think about it, this person very possibly measured the time taken for ice to melt more than one time for each water temperature. However, in this case, we are only going to graph the averages, and that is always the case. We only graph the averages. We do not graph the results, the raw data, each one of the individual results. We only graph the average. So let's proceed to draw the graph. So I have my graph paper, and we must always remember to use a sharp pencil to draw our graph. So let's look at the scale. Let's remember that the scale needs to be evenly distributed, and that we must put the independent variable in the x-axis. So the independent variable in this case is water temperature. We must always also remember to include the unit of measurement. So in this case, the unit of measurement is in degrees centigrade. So it's water temperature and in degrees centigrade. The dependent variable goes on the y-axis. Let's remember that we only graph the average. And in this case, the dependent variable is the time taken for ice to melt. Let's remember we always need to include the unit of measurement. So in this case, the unit of measurement is in seconds. We now need to choose a suitable scale. So let's remember that the scale needs to be even. Yeah, so in this case, we can do it maybe every 10 degrees centigrade. Now, let's consider that the first water temperature is 40 degrees. Now, I could start it at 0 degrees, but I would be wasting some of my scale. Let's remember that 0 point cannot change. That is the origin of the graph. So let's look at the scale. I could start the scale at 0, but then my first water temperature is 40 degrees, or I could skip part of that scale. To represent that I've skipped part of the scale, I could represent it in this way. That represents that I've skipped part of the scale, and that is totally fine. I then start my scale, 40 degrees, 50 degrees, 60 degrees, 70 degrees. Yes, now I can make my scale a bit longer, if I need to. Please remember, you must always use a ruler and a sharp pencil. So that we have at 70 and then at 80 degrees. That little arrow shows that water temperature could be done, that the temperature could be higher than that, so that the scale continues. So we have water temperature, our independent variable, on the x-axis. Now we need to choose a scale for the dependent variable. Now in this case it's a bit more tricky because the dependent variable is less regular, yes? But it would be incorrect to have a scale with 10, 14, 20, 24, 32, because that would mean that the scale is uneven. So in this case, I could also do it every 10 seconds. So here we have 10, 20, 30, 40 seconds. So now we will proceed to graph our data. So in this case, the way we could graph our data is using, in that case, we have shown that the axis continues, and we will proceed to graph our data. So at 40 degrees, the average time taken for ice to melt is 32 seconds. So we go 40, 32, each little square is worth 2 seconds in this case, because that's the scale I selected, and I represent this using a cross. Crosses are the best way to represent my data on a graph because they make it very, very clear. So at 50 degrees, it took 24 seconds for the ice to melt, so that is where 24 is on my graph. At 60, it's 20. It would be a really good idea for you to be doing this at home as you watch the video. You can pause this while you watch the video, just to make sure you draw the graph correctly using that data. And then at 80 degrees, it took 10 seconds. Now it's time to draw a line or a curve of best fit. A line or a curve of best fit basically shows the general trend of the data. So in this case, we draw a line of best fit, not a curve, just because that's the way the data is best represented. Now when we draw a line of best fit, we need to try and cross as many, the line of best fit needs to represent the general trend as much as possible. So I need to have the same number of crosses on either side of the line. So in this case, that is the line of best fit. It doesn't necessarily have to cross every single data point, as long as we have the same number of crosses on each side of the line. So as you see, this is the line of best fit in this case. Now the correlation is not very strong because the data is quite spread out. Yes, but that is the line that best describes the general trend. So in this case, we use a transparent ruler to figure out what the line of best fit would be in this graph. So that closely represents the general trend in this particular graph. As you can see, we have the line crosses most of the data points, and it has one cross on the top and one cross at the bottom of the line of best fit. The next step, and something we always have to remember, is to come up with a title. So the title needs to have both the dependent and the independent variable. So an appropriate title would be the relationship between the water temperature and the time taken for ice to melt. So as you can see, this title has both the independent variable, water temperature, and the dependent variable, the time taken for ice to melt. That is the dependent variable. So this is a concise, descriptive title. Thank you.